Hello, my name is Anthony, and today I will be reviewing Chapter 5, Wood Light Frame Construction. Timbered frame buildings originally required heavy posts and more money to be built. Light frame construction was discovered after realizing that closely spaced vertical members or studs were strong enough to hold on their own. This led to the development of the balloon frame, which used closely spaced wooden members, joists for floors, studs for walls, and rafters for roofs. This eliminated the need to place heavy posts and beams, reducing labor costs drastically. Construction became really simple. Even an observer noted in 1865 that a man and a boy could accomplish what once required a team of 20 workers. However, the balloon frame had two major flaws. Its long vertical studs were heavy and very difficult to handle. They were tall, hollow wall spaces that acted like chimneys when a fire starts, spreading flames rapidly. Platform frame. Something new had to be created, which led to the rise of platform frame. It is a standard today. The platform frame is building a floor at a time. A floor platform is built first. Load-bearing walls are raised on top of the platform. A second floor platform is constructed on top of these walls, followed by another set of walls. The attic and roof are then built upon the second set of walls. This new build has several advantages over the balloon frame because the lumber used is typically shorter and easier to work with. The way the platforms are placed, it works like individual sections that help stop fire from spreading. Lastly, each floor serves as a working platform for builders, increasing efficiency. There is a small downfall to this build: vertical shrinkage. Since each floor platform consists of wood with horizontal grain, which shrinks over time as moisture dries out, if not dealt with correctly, this can lead to cracks and structural adjustments in the building's finished materials. The platform frame is constructed using nominal 2-inch thick lumber, which is 1.5 inches in real dimensions. Lumber is cut to length on site or pre-cut at the lumber yard for efficiency. Nails are the primary fasteners that are easy and quick to install without the need for complex joinery. Each structural plane is built with a grid-like arrangement of members. In the floor system, joists are aligned parallel to one another and capped at the end with rim boards or band joists, then covered with subflooring. In wall framing, vertical studs are secured between a sole plate at the bottom and top plate. Roofs have a similar pattern with a ridge board at the peak. Buildings often require openings such as windows, doors, staircases, and chimneys. Additional framing elements like headers, trimmers, and sills help reinforce these gaps. Larger openings use a double-up framing members to handle increased structural loads. A crucial component in this build is ceiling, which provides strength and stability. Panels of plywood or oriented strand boards, which also known as OCB, are nailed over the framing to create a rigid structural unit. It not only creates great support for plywood, but it also helps significantly resist wind and earthquake forces. Without seating, buildings wouldn't be able to resist strong forces that detach roofs and walls. Standard spacing is typically 16 or 24 inches on center, ensuring materials align correctly and reducing waste. Advanced framing. Since its creation, the 2x4 wall stud has been the standard for light framing. As energy conservation became the priority for every build, we had to integrate better insulation without affecting structural integrity. Some framing techniques had to be implemented to improve lumber usage and its thermal efficiency. Larger studs allowed for wider spacing. Using a 2x6 strut at 24-inch spacing instead of a 2x4 at 16-inch spacing creates better insulation cavities while reducing the number of studs. But it also decreased thermal bridging, which is a major cause of heat loss. Modular design is designing a building to fit a 24-inch grid to minimize wasted materials from framing lumber and interior wallboards. Techniques like using single-top plates, removing unnecessary headers, and replacing jack studs with metal hangers help save wood while maintaining its strength. Replacing plywood with insulating sheathing and non-structural walls, builders can use insulating sheathing to improve thermal performance. These techniques cut lumber usage by 19% and boost energy efficiency by 30%. As a result, it is a stronger, more sustainable, and cost-effective homes. Prefabricated framing is changing the way construction is done. Roof and floor trusses allow for faster assembly, longer lifespans, and material savings. Panelized wall sections are pre-framed and sealed in factory, allowing them to be delivered to the site ready for installation, speeding up the building process significantly, especially for large-scale buildings. While these techniques advance, careful planning is required to offer huge benefits in efficiency and sustainability. A two-story suburban house using platform framing. A concrete slab is placed down. A crawl space is a raised foundation with a limited access. A full basement, common in colder climates for insulation and additional storage space. The foundation provides a stable and level base for the entire structure. The first platform is built directly on the foundation. This includes sill plates, threaded wooden boards anchored to the foundation with bolts to prevent movement, floor joist, horizontal wooden beams, typically 2x10s or 2x12s, spaced about 16 inches apart to support the floor. Subflooring, large plywood or oriented strand board, which is OCB, sheets nailed to the joints to create a strong walking surface. The house has a solid first floor platform, ready for the walls. Once the platform is complete, the walls are built one at a time, while lying flat on the ground before being raised into place. Wall studs, vertical 2x4 or 2x6 wooden studs, spaced 16 or 24 inches apart. Top and bottom plates, horizontal beams connecting the tops and bottoms of the studs for stability. Doors and window openings, framed with extra support, headers and trimmer studs to handle loads above openings. Seating, plywood or OCB panels attached to the exterior for additional stability and weather resistance. Once all four walls are raised and secured, the house begins to take shape. After the first floor walls are completed, another platform is built for the second floor. Floor joist, placed on the top of the first floor walls, spanning across the house. Subflooring, plywood or OCB sheets nailed down to create a sturdy second floor base. The first floor is enclosed, and workers can walk safely on the second platform. The second floor walls are framed just like the first floor. Studs, plates, and headers are assembled on the floor. The walls are lifted into place and secured. Since platform framing allows for independent construction of each level, it's safer and more efficient. The final major step is adding the roof. Roof trusses or rafters. Prefabricated trusses or custom-cut rafters are placed on top of the second floor walls. Roof seating, plywood or OCB panels create a solid base for shingles or other roofing materials.
So the next part is about the foundations for wood light frame structures. Most residential and small commercial wood light frame buildings are built on shallow foundation consisting of spread footings, basement or crawl space walls, or slab and grate. For larger buildings or where the soil conditions close to the surface are problematic, we need deeper foundations. For simpler basement and crawl spaces, protection from the water entry usually takes the form of bituminous or cement plaster damp-proofing applied to the outside of the foundation walls, along with the drainage with materials surrounding the basement walls and perimeter footing drains to draw the water away. So the step one in the construction of a simple platform frame building is establishing the location of the building on the site. Then, after the corners of the foundation have been stacked, batter boards are erected safely beyond the limits of the excavation area. A string line crossing over the corners stakes are stretched from the batter boards, and the position of the boards are preserved with notches or nails in the boards. Later, after the excavation, the strings are stretched again, and the foundation corners can be relocated at the bottom of the excavation. The step 2 in the construction of a typical platform building is the excavation and foundation. So the next part talk about the foundation insulation strategies. The need for insulation and the amount varies depending on the climate zone and energy code requirements. There are different types. The first one is the foam plastic on the outside of the foundation walls can align with the continuous insulation on the wall above. In full height basements, insulation under the basement slabs is not normally required, Next, we have when the insulation is applied to the inside of the basement wall, air impermeable rigid formboards may be used to prevent warm interior air from reaching the cold concrete wall surfaces and causing condensation. The board should be made airtight with taped or sealed joints. For additional insulation value, less expensive batt insulation can be added over the rigid boards in the joints bay ends. Springform is easier to install tightly in these irregular shaped spaces than rigid boards. When facing the building interior, plastic form insulation must also be covered with a layered gypsum wallboard or other fire-resistant material to delay the release of toxic gases in the event of a building fire. When crawl spaces are insulated, the strategies are much the same as for the basement. However, because crawl spaces do not extend as deep into the ground, insulation under the perimeter areas of the slab may also be required. When plastic form insulation is exposed in crawl spaces, it must be protected with an ignition barrier facing or finished material that reduces the risk of fire. When a crawl space is ventilated to the exterior, the floor above must be insulated as well. Rigid insulation underneath the floor joints, though not required by energy codes, reduce thermal bridging and protect the joints, and insulation above from high humidity in the crawl space. When a slab on a crate is connected to the foundation wall, insulation is applied to the exterior. The energy code requires a minimum depth of insulation that may extend downward or first downward and then outward from the foundation wall. When the slab of the crate and foundation wall are not connected, insulation may be also applied under and around the edges of the slab. Energy conservation codes require foundations to be insulated to reduce the exchange of heat with the surrounding soil. Some insulation materials are unaffected by moisture and sufficiently dense that they can be placed on the outside of the foundation wall prior to the backfilling or under a slab on a grate before the slab is poured. Many more insulation types can be applied to the inside of the foundation. So the next part will be building the frame. First, you need to plan the frame. An experienced carpenter can frame a simple building from the most minimal drawings, but the framing for a larger or custom designed structure may have to be planned as carefully as for the steel or concrete structure. The architect or engineer determines an efficient layout and the appropriate sizes for joints and rafters, and communicates this information to the carpenters by the means of framing plans. For most purposes, member sizes can be determined using standardized structural tables that are part of residential building codes, or for more complex framing or specific conditions, engineering may also be required. The architectural drawings are technical representation of a building or structure used to communicate design intent, construction details, and spatial arrangements. These drawings serve as guide for architects, engineers, and buildings through the design and construction process. There are different types of architectural drawings. First we have the site plan, which is a top-down view showing the entire property, including the building footprint, landscape, pathways, roads, and utilities. Also includes property boundaries, zoning details, and environmental factors. Also, we have the floor plan, a horizontal cut through the building at a specific height, which typically is 3 to 4 feet above the floor, showing room, layouts, doors, windows, and furniture. These include dimension, wall thickness, and circulation paths. Also, we have the elevation drawings, which are the exterior elevations which show the front, rear, and sides of the building, indicating materials, heights, and openings. And also we have the interior elevation, the big details such as built-in furniture, wall finishes, and cabinetry. We also have the section drawings, which are the vertical cut through the building, illustrating structural components, ceiling heights, and relationship between the floors. These ones are used to show details that are not visible in the floor plans. Also, we have the detailed drawings, which are zooming in views of specific elements such as staircase, doors, windows, and connection. typically draw at larger scale to provide clarity on construction techniques. Also, there are another type of drawings, which are the structural drawings. These ones show the framework of the building, including beams, columns, foundations, and load-bearing elements. These ones are used by structural engineers to ensure the building stability. The next type of buildings are the MEP building, mechanical, electrical, and plumbing drawings. The mechanical drawings show the HVAC, which are heating, ventilation, and air conditioning systems. In part of the MEP drawings, we have the electrical drawings that indicate the wiring, outlets, lighting, fixtures, and circuits, with the plumbing drawings, which illustrate water supply, drainage, and piping layouts. And finally, we have the RCP drawings, which are the reflecting ceiling plan. This one is a mirror view of the ceiling layout, which show lighting fixtures, air vents, and ceiling details. This one helps to coordinate electrical and mechanical installations. Thank you.
The passage discusses alternative foundation materials and framing planning, focusing on wood foundations as a versatile construction option. Wood foundations can be constructed in any weather conditions made from preserved treated wood panels, particularly useful in extremely cold regions, where concrete is impractical. Allow easy insulation and accommodate electrical plumbing installation installed by the same carpentry crew that will frame the building. Alternative foundation systems. Insulating concrete formwork. Use permanent insulating forms, precast concrete panels, factory fabricated, quick to erect, and can include integrated insulation. Framing planning. Simple buildings can be framed by experienced carpenters with minimal drawings. Complex structures require careful planning, similar to steel or concrete construction. Framing plans communicate technical details to construction crews. Standard structural tables in building codes help determine member sizes. Complex framing may require specialist engineering. Rafter and truss sizing. Rafter span depends on wood dimensions 2x4 to 2x10. Roof truss depth typically 1/4 of building wide. Trusses usually spaced 24 inches apart. Maximum truss span around 65 feet. Joint sizing recommendations. Wood floor joints span different distances based on their size. 2x6 joints span up to 9 feet. Manufactured wood I-joints have increasing span lengths with greater depth. Structural support capabilities. 2x4 studs at 24 inches support attic and roof loads. 2x4 stud at 16 inches or 2x6 stud at 24 inches support one floor plus roof. 2x6 stud at 16 inches support 2 floors plus roof. Framing characteristics. Typical framing member spacing 16 or 24 inches and are preliminary and not for final sizing. Applicable to residential, commercial, and institutional buildings. Building code classification. Wood-like frame. Combustible construction system permit in types 3 and 5. Usually classified as type B and added fire protection. Restriction on building height and floor area. Fire safety considerations. Recognizes the least fire resistant construction type. Building codes provide flexible usage limits. Alternative firewall solution using metal framing and gypsum board exist. Comprehensive life safety requirement ensure occupant protection. Economic and design advantage. Highly attractive to building owners due to cost effectiveness, prefer over more expensive fire-resistant construction methods, offer exceptional design flexibility. Construction characteristics. Adaptable to diverse building uses, capable of creating structures ranging from simple to complex design. Economically, competitive construction approach. The WG log house examples illustrate how wood-like frame construction can achieve architectural sophistication while maintaining fundamental simplicity. Despite inherent fire vulnerabilities, strategic building code regulations and construction techniques make this method a popular and viable choice for many construction projects. The text emphasizes wood-like frame construction as a pragmatic building approach that successfully combines economic efficiency, design versatility, and safety considerations. Architectural drawings and the construction of wood-like frame buildings. It explains that floor plans show all locations and dimensions, while exterior elevations display the building outside faces. Building sections provide a cross-sectional view, revealing the relationships between floor level and roof planes. The text focuses on platform frame construction, a method where each floor platform serves as a work surface for the next stage of building. This approach minimizes the need for ladders or scaffolding and requires minimal temporary bracing. The construction detail, including member sizes, spacing, and egg connection, are standardized and regulated by building codes. The illustrations highlight specific framing techniques such as maintaining consistent joint spacing, using double headers and trimers around openings, installing sheet metal joist hangers, supporting cantilever section with special framing, and ensuring proper moisture protection for exposed framing. The overall emphasis is on the systematic and precise approach to constructing wood-like frame buildings with attention to structural integrity, building codes, and practical construction methods.
Going to the examples, we will have different type of styles that use this type of wooden frames. The first one was the Carpeting Gothic, which is the 19th century architecture style that adapted all the details of European Gothic architecture to the simply wood frame construction method of North America. Instead of stone, builders use wood, allowing for delicate, ornate, and sometimes mystical designs. One clear example of this type of style will be the Gingerbread House by Martha's Vineyard. This is located in Oak Bluffs in Massachusetts. This house is one of the many in the historic Martha Vineyard Camp Meeting Association, and the house is built using balloon framing. It features decorative baseboards, pointed arch windows, and steep gablet roofs. Unlike the traditional Gothic revival building, which relied on stone for verticality and ornamentation, the gingerbread house achieved this look of using affordable and easily worked wood. The carpet and Gothic houses, like the gingerbread house, show how light wood frame construction can be used for more than just a basic shelter. They can create artistic and highly crafted buildings. Another different style which used also the wooden construction would be the Bay Region style, which emerged in mid-20th century in Northern California. The style combined contemporary aesthetics with traditional craftsmanship, often emphasizing exposed wood and natural materials. One building from this style would be the Sea Ranch Lodge in California, which was designed in the 1960s. The building frame is constructed using a platform framing, a modern improvement over balloon framing that allows each floor to be built as a separate unit. We also have exposed wooden beams and trusses, give the interior a rustic but modern aesthetic, showcasing the beauty of the wood itself. Also, the wood is left unfinished or treated with natural stains. Also, we have the steeply pitched roofs and use of large wooden panels reinforce the structural ability to withstand the region's strong coastal winds. The Sea Ranch Lodge demonstrate that wood-like frame construction is not just inexpensive houses. It can be used to create a high-design, environmental integrated buildings. And that will be all the examples. Thank you.